Homework 4 is on factoring polynomials. So we have a bunch of different rules. You guys are going to be paying attention to how many terms there are. Is it 2 or 3 or 4? Is there a GCF? You should always be looking for a GCF as your very first step. So I'm going to do 3 different examples for you. The first one I'm going to do is number 11, the bottom of this first page here. So I just mentioned the GCF. You should always look for a GCF first, no matter if there are 2 terms or 3 terms or 4 terms. So here we look and we compare this term to this term, see if there's anything that they both share that we'd be able to factor out. Notice that this one has copies of y and so does this. There are at least 2 copies that we could factor out. So we're going to take y squared and then write the leftovers in parentheses. So this is an x cubed minus, and then this is 343 y cubed. All right, so GCF is first step always, and then you look in the parentheses and you see, is there something that I can do to further factor this down? And with this, there are 2 terms. So 2 terms is one of these 3. So when you guys are doing the homework, you should have these rules sitting right in front of you. So difference of squares, sum of squares, difference of cubes are your options for 3 terms. With number 11, it's not addition, so it's definitely not the sum of cubes. And if you look, these are definitely cubes, not squares. All right, so this is a perfect cube, this is a perfect cube. So the next thing you would want to do is write them out as their actual cubes. So this would be x cubed. That one's pretty easy. And then the 343, this one's maybe a little bit lesser known, but this one is 7. All right, so the 343 is 7, and then there's a y, and that is cubed. So picture if you were to multiply 7y times 7y times 7y, that would give you the 343y cubed. All right, so you get it in this form, and then when you're looking at this formula that you'd have written out up here, you just copy in the x for each a, and then the b you'd replace with a 7y. So I'm just going to write this formula just so you have it up on the screen. So it would be a minus b, a squared plus ab plus b squared. All right, so for our final answer, with that y squared, you'd still write it out front as a GCF, and then the a minus b becomes x minus y, or 7y. And then for these next terms, a squared, so I square this x, and that gives me x squared, plus a times b means I multiply these 2 values together, so x times 7y, I'm going to write it as 7xy, plus, and then finally b squared means I square the 7y, so 7y times 7y would be 49y squared. So that is as far down as I can take this. Remember, you also answered, how can you tell if it's completely factored? So you should be looking to make sure that there's nothing that you can do to factor any of these down any further. And once you do the difference or the sum of squares, once the GCF is taken out, there isn't any further that you can take this. All right, we're going to do 2 more on the next page as well. I also want to do number 18. So this one, no matter how many terms there are, remember I mentioned you're always looking for a GCF first. So if you look among these 3 terms here, you can see they all have copies of m. So I could take out 2 copies of m, and I'm going to write my leftovers. So this is an m to the 4th minus 7m squared minus 18. All right, so we start with that. And then you look inside the parentheses. So inside the parentheses is a trinomial, so it's not really any sort of fancy factoring pattern. You are just going to factor it down like your normal 2 sets of parentheses. All right, and no coefficient in front. So this m to the 4th would just be m squared times m squared. And then for our constants, we're looking for them to multiply to a negative 18 and add to a negative 7. So multiplying to negative 18 and adding to negative 7 would be negative 9 and a positive 2. Remember, every factor that you come up with, you should always be scanning it to see if it can break down further. M squared is our GCF, so that doesn't do anything. M squared minus 9, you should recognize that as the difference of 2 perfect squares. All right, x squared and then, m squared and then 9 are perfect squares. So that pattern would be m times m, and then the negative 9 would be a minus 3 and a plus 3. And the fact that they're opposites is what makes our middle term cancel out. That's why we don't have one. This term, something very important to note is that you do not have a sum of 2 squares, and 2 is not even a square at all. So this one, the m squared plus 2, doesn't actually factor down any further. So this would be completely factored for number 18. Okay, one last one I want to do is number 21. I want to include one that has 4 terms as well. So that is the factoring by grouping. So we are going to group these two together, group these two together. We're going to start by looking for a GCF. So between these two terms right here, the x cubed, the x squared, they have an x squared in common. I can write my leftovers in parentheses. So when I factor out an x squared, this first term is just an x. Factor out a -7, x squared, and all I have left behind is the -7. Next, these two, the x and the -7, don't have anything in common. So whenever that is true, you're going to write a +1. Okay, that just means there is no GCF, so you can think of it as always being a 1. And then since I didn't factor anything out, it stays the exact same in parentheses. The reason I did that was because my factoring by grouping, I have to have this identical term right here, right? So now you can think of kind of this is one term, and this is one term. And you'll see that they each have an x minus 7 in parentheses. So we can factor out the x minus 7 as if it's a GCF. And then once that GCF is gone, you can see you have an x squared plus 1 left behind. So that's going to be your second factor. Always scan to make sure there's nothing else you can do. This, don't get too tempted or too tricked by this. There is no sum of squares. Okay, because they wouldn't end up canceling each other out because you'd have a positive 1 and a positive 1, which would automatically give you a middle term, unlike something like this where the middle term would end up canceling. So this is actually as far as number 21 can be factored down.